In the previous videos, we looked at being able to work with degree and radian measures and converting back and forth and plotting. We're going to look at one other concept that's going to be pretty fundamental to our remaining study of trigonometry, and that's radian measure. And then we're going to kind of expand upon some of the things that we did earlier. We want to find the radian measure of the central angle of a circle of radius 8 yards and an arc length of 11 yards. So one thing that we should do is we should remember a formula that we saw at the very beginning, and that's where we have theta equals s over r, where the arc length is f's and r is the radius, okay, of some sort of circle that we're trying to inscribe that central angle in. And so this is what we really have. Okay, so let's say, for instance, this is our radius r. All right, and I know that's not a good radius. It's definitely not the center of the circle. So we try that again. All right, and I know it's not a circle, so just humor me. And this is our radius r, which is going to be 8 yards. Now, we're saying that the arc is a length of 11 yards. So we have another radius here. And let's just assume that this is our S. Okay, in fact, maybe if I draw that in a different color, it'll be a little more visible. All right, so this is our arc length S right here, and that's going to be 11 yards. All right, and what are we looking for? We're looking for the central angle here, which we call theta. Okay, how many radians is that? And so to figure that out, what we're doing is we're taking theta equals S over R. Well, S is 11 yards, and then we have 8 yards, okay? And so the yards would cancel out, and so our theta would be 11/8 radians. Okay, so that's all there is to it. We're not trying to put that in terms of pi or anything like that. We certainly could if we really wanted to, but no need to do that. Another example, we have a radian measure of the central angle of a circle that has radius 3 meters that arcs of a length of 600 centimeters. All right, so this is what I commonly see from students is they say, okay, well, theta equals S over R, so that's going to be 600 over 3, or 200. All right, and unfortunately, that's not the case with this one, because I want you to notice that there is a discrepancy in the units. One is centimeters and one is meters. So what we should do is we should take our 600 centimeters and we should convert that, because we know for every 1 meter, there's 100 centimeters. Right? And so that would just be equal to 600 meters over 100, or 6 meters. All right, so that's going to be our S. And so when we go to compute this, okay, now we have 6 meters divided by radius 3 meters, and that's just going to be equal to 2 radians. Okay, so essentially, it's just going to be twice the distance of the, or basically, it's going to be twice the measure of one of the arcs. Okay, or 2 arcs essentially is going to be that central angle. All right, now a kind of problem that's going to kind of throw everything together. And it looks like kind of a repeat of what we've done earlier, and some of it is. We're going to take angles that are a little bit bigger or smaller than the 0 to 360 domain that we are accustomed to. So what we're going to do is we're going to take these angles, we're going to draw them in standard position, we're going to convert from degrees to radians, and then we're going to find a coterminal angle between 0 and 2 pi, both in radians and degrees. And then we're going to find another angle between -2 pi and 0, both in radian and degree. All right, so here's the way I think about this. Every time that we complete a revolution, we're going to add 360 degrees. Okay, so let's draw this first of all in standard position. All right, so when we construct this, now remember it's negative. Okay, so let's start here. All right, and if we start like at this term at the standard position and we go around once, okay, that angle right there is going to be -495 plus 360. Okay, so all we've done is we've gone through, added 360 to that, and that's going to give us 135 degrees negative left. Okay, so that tells us how much we have left. And in fact, that's going to help us to figure out a coterminal angle a little bit later. Right? Now we know 135. Okay, so we go from here to here. That's 90 more, and that's going to leave us with -45. And so we know 45 is just about halfway through. Okay, so this would be our angle. Okay. This is going to be theta equals negative 495 degrees. All right. So that's how we would try to work this. We just want to keep going around and maybe adding 360 each time. If we want to convert from degrees to radians, that's easy. We can do that with our calculator. So we have negative 495 degrees, and we're going to multiply that by pi over 180 degrees. That's where we go into our calculator, and we're going to just take our negative 495. We're going to divide that by 180. All right, that gives us 2.75 or negative 11 fourths. And so when we write this up, that's going to be negative 11 pi over 4. All right. If I want to convert that into degrees, okay, what I would do is, or it just says to convert it to radians. All right, so when we get our coterminal angle, that's going to help us. All right, so next thing we want to do is we want to try to get a coterminal angle between 0 and 2 pi. All right, so basically within our between 0 and 360. So here's an easy way to do that. Just take your negative 495 and just add 360. And if we add 360, which we already did right here, that gives us negative 135. So that's a coterminal angle. What we need to do, though, is we need to add another 360 to that, right? And all we just keep doing is we just keep adding 360 degrees each time until we get to a number that's going to be between 0 and 360, okay? And so if we just go into our calculator, we can take that 135, add 360. So we have our negative 135 plus 360, and that gives us 225, all right? So that's going to be 225 degrees. It also asks us to put that into a radian measure. So we would take 225 degrees, multiply that by pi over 180, and we just go into our calculator, and we could just take our 225 divided by 180, and we could just do fraction or hit math, enter, enter. We get 5 pi fourths. Okay. Letter D is even easier because we've already done that. Okay, so now what we want to do is we get an angle between negative 2 pi and 0. So basically, remember, that's between negative 360 and 0. This is between 0 and 360 for 0 and 2 pi. All right, so for letter D, we take our negative 495 degrees, and we're going to add 360. And we already did that. We got negative 135. And that number is between negative 2 pi and pi, or between negative 360 and 0. If we want to convert that into radians, we just take that negative 135 degrees, multiply by pi over 180. And if we could go into our calculator and do that, okay, so that's going to be negative 135 divide 180. That's going to be 3/4 or negative 3 pi fourths. All right, so that's going to be our negative 3 pi over 4, and we are done with that example. Okay, so nice and easy. Okay, notice that there's no real algebra involved in this. Okay, all we're really doing is just adding and subtracting 360 a lot of times. Okay, or 2 pi, etc. One last example before we complete this video. We have 750 degrees, and we want to do the exact same thing. So first things first, let's try to draw the angle in standard position. All right, so over here, what I'm going to do is I'm going to take the 750 and I'm going to go around once. Okay, and when we go around once in the counterclockwise position, that means we're taking out 360 degrees. Okay, so if we do that, that's going to leave us with 390 degrees. Then what I'm going to do is I'm going to do another full rotation. All right, and I'm going to subtract another 360 degrees, and that's going to leave me with 30 degrees. All right, so I'm going to just draw this last 30 degrees. All right, and this angle right here is going to be our 750 degrees. All right, so we just keep going around, eliminating 360s or subtracting 360s each time. All right, so that's pretty easy. Next thing that we're asked to do is to convert from degrees to radians. Okay, so this is A. For letter B, we just take 750 and we're going to multiply that by pi over 180, right? And then we just go into our calculator. We're going to take 750. We're going to divide it by 180. We're going to hit math, enter, enter, or we're just going to use this fraction, 25 over 6. We're not going to forget the pi. Okay, so this is going to be 25 pi over 6. Okay, so that's pretty easy. Next thing we need to do is we need to find a coterminal angle that goes between 0 and 2 pi. But the good news is we already have one. Okay, all we did was we just subtracted 360 a couple times. Okay, so that's the way we want to try to do this. So 750 degrees, right? So just to remind you how to do this, what you do is you just keep subtracting 360. All right, so remember we subtracted 360 once, we got 390. We're going to subtract 360 again. That gives us 30 degrees. All right, so that's the angular representation. And then what we're going to do is we're going to multiply that by pi over 180, and that's going to give us the radian measure of that. Okay, so we just go into our calculator, and that's going to give us pi 6. Okay, so we get 1/6. We can't forget the pi out of that. Right, so that's the radial measure of that, or the radian measure. Now, if we want to try to get an angle that's between negative 2 pi and 0, well, guess what we're going to do? We're going to take this 30 degrees and we're going to subtract another 360 from that. All right, so basically we just keep subtracting or adding 360 each time till we get to a number that's between positive 0 and 360 or negative 360 and 0. Okay, so we take our 30 degrees, we subtract 360 degrees. That's going to be negative 330 degrees. If we go into our calculator, and I believe we did this problem earlier today, that should be negative 11 pi 6. All right, so we're going to take our 330, divide it by 180, math, enter, enter, 11/6. We can't forget the pi. All right, so we just take negative 330 times pi over 180, and that is going to be an 11 pi over 6. All right, so that's how we can take these larger degree measures or smaller degree measures, these angles that are not between 0 and 360, and kind of make these coterminal angles. Okay, this is going to be really important later in the course. Okay, so this is a skill that has to be fundamentally understood before we can go through and do some sort of higher order sort of trigonometric operations. Next video, what we're going to do is we're going to do the opposite, and we're going to have the radial measures that are beyond 0 and 2 pi, or less than 0 and 2 pi. And we're just going to convert those into degrees. We're going to plot them. We're basically going to do everything that we did just here, but in radial measure.